Chapter 15, Sample Problem Number 11. Water flows through a circular pipe from one section into a different one, with the various parameters on either side of the junction listed below for 5 different cases. Consider the speed of the fluid flow in the right half of the pipe in each case, given the information listed, and then check the appropriate box. So we're going to be looking at the speed of fluid flow in the right half. And for this, we're going to use the equation of continuity, which tells us that the density times the area times the velocity is constant. And this is coming down from the idea that the same amount of volume of water must every delta t move from here to here, and since in that delta t it must travel further, it must have a higher velocity since it has less height, less area. But we do have to be careful that it's the area and not the radius. So we end up with, if we look at this, that the new velocity is the original velocity times the ratio of the areas, which is the new velocity times the square of the ratio of distances. So our original velocity in A, for instance, was 10, and the ratio is 2 to 1. So the new velocity would be 10 times 2 squared, or 40. Call this V2, would be 40 meters per second. And then likewise for B, we have a ratio of 3 to 1, so that's 9 times as large, so this is 90. And here we have a ratio of 3 times as large, so that's 9 times as much, and is also 90. In case D, we have 4 times as much here. We square it, that's 16, and we multiply by the 5 to get 80. And then here we have 50 over 40 squared times the 30, and that turns out to be just about 47. So we see that we have B is the same as C. They're both bigger than D, which is bigger than E, which is bigger than A.